Hi, I'm Eric.
I'm Pam.
So this is Ops for NoOps, Operational Challenges for Serverless Apps. I've also called it 2001 Challenges, which hopefully there aren't that many challenges, but there definitely are a lot of GIFs from that movie. Oh, cool, so you added that.
Oh, yeah.
Yeah, Pam updated the slides last night. I haven't seen them yet, so...
It adds a little bit of excitement. It's the morning. We appreciate you coming to the morning session. So why not keep it interesting?
Yeah. So we'll discover the slides together. Cool.
But yeah. So Eric, founder, CTO, IOPipe. I'm software engineering lead, professional nerd, amateur humorist. We'll see how that goes.
Cool. Let's go. Yeah. So on the previous slide, I said in the destroyer of monoliths. I've been working in cloud for a long time. Kind of taking those siloed applications, monolithic applications, and breaking them down. I've seen these applications back from like 2003 or 2002, and helping users build, take platforms of service and deploy those applications. And, I went to Docker, we were building microservices, and now with serverless, right? We're kind of getting to this like micro application function level programming. And it's a new way of building these apps, but this evolution creates challenges, right? And every time we've had these changes, when I first started helping users with breaking down into like microservices type architectures or scalable platforms of service, a decade ago or 2 decades ago, right? There was this fear, uncertainty, and doubt, right? What problems am I going to run into with this new platform? How do I use it? How do I know about these problems when they happen? How do I know how to fix them? Where they are, is it secure, right? Like Docker, everybody's like, is it secure? I'm like, this is a security product, right? Nobody at Docker, besides myself maybe, really wanted to say that, but it was a security product, right? We're taking like primitives of the operating system security features of Linux and enabling them where they weren't enabled before. So there were users saying, hey, well, is Docker secure? I'm like, well, of course Docker is secure. You're taking Linux and then you're enabling all the security features that you weren't using before. So of course it's more secure. But right, these are like the questions that users have. And certainly what happens is, just like with serverless for security, is that users ask questions they may have not asked before, right? They're not new problems. They're just the lack of other problems starts, you begin to look at the problems that like, the ones that remain, you start concentrating on them more and focusing. That's actually a really great thing for our industry, right? Because now we are caring about things that we should have always cared about and never had time for, right? And then, what tools we use to manage this and to solve these problems.
Yeah, and that's a really nice thing about being here at Serverlessconf is we're in the room with a lot of people who made these tools, and there's the joy of the problem of choice, that we have lots of frameworks that we can choose from, and of course you can always have bespoke. You can run your functions from lots of event sources. You support languages, and we keep adding more language support, such as Swift, this is all really great to be able to run these in this new environment, run it in wherever you want. And in terms of seeing, one of the nice things that we've gotten to do with working with users running on function as a service platforms is seeing just the different usage patterns. So you see people who run a function once a week, and you see people who run, hundreds of millions of events in a day. And you can run all this in the cloud, dev, test all the way through production.
Yeah, and I just wanted to add a couple things. First of all, the Swift support was built here in London, which is really cool. But then also, because we don't mention it here, it's like, it's not just Lambda, right? This is actually kind of an old slide because at some point it was only Lambda. Now we have Azure functions, we have Google Cloud Functions, we have OpenWhisk.
Webtask.
Webtask, and some of the DIY solutions, right? Like on-premise solutions, in your own infrastructure, in your own EC2 instance solutions too, right? So cool.
Yeah, definitely. But of course, then the other half of these things is that lots of change and lots of things. The other word for that might be instability. And so, what do we do when things do go wrong? And so that's the challenge and the question we have.
Yeah. So what Amazon offers, and this talk is a little bit focused on Lambda because this is where most of our users, where we're seeing users using serverless in production today. These other platforms, as great as they are mostly in beta and alpha states. So the users that we're speaking to, they're using Lambda for now. But CloudWatch, right, provides what I call super outside metrics. It gives you errors, logs, invocations over time, duration, and memory. Interestingly, memory is not a metric in CloudWatch. It's a log statement. So you need to actually build tooling around the logging to extract that and deliver it as a metric, which is super weird. I imagine it'll get fixed eventually. Datadog, Sumo Logic, a couple other companies can ingest these CloudWatch these metrics and these logs and understand them. But right, these platforms can't really understand anything more than what CloudWatch gives you. This is useful information, maybe not so useful the way CloudWatch presents it, but the information is somewhat useful. But there's so many other problems that users have today on Lambda that these metrics don't give you. So one of the big ones that we hear from users, and honestly something that you can't do too much about, is cold starts. You can definitely understand cold starts, and you can sometimes prevent cold starts from happening. You can prevent retries of your application, which are pseudo cold starts. You have cross-invocation leaks, memory leaks, file descriptor leaks, backend process visibility, thread callback leaks. I was talking, so there's a Slack for serverless developers, the Serverless forum. Some of you might be on there. There's not many people in there, but it's Patrick DuBois was having an issue with file descriptor leaks, and Patrick found it DevOps days. He's an early person in the DevOps community, and he was having like really hard time debugging and fixing a problem with file descriptor leaks in his Lambda functions, right? And if like the founder of DevOps days can't fix his application, right, due to these problems, like what's the chance that your developers in your organization or yourselves are going to be able to solve this problem, right? So you need tools to help you, and there's all these other problems, right? Retries, profiling tools, just general debugging and visibility into distributed systems. I think we can skip, right? State management, the understanding of where you're putting your state, how long it takes to get your state, the security aspects around the access of that data, who can get it, when they can get it, AIM policies, for instance, general security, compliance issues, dependency management. Sorry. I know, I'm reading off a slide. I hate that.
No, your phone just buzzed, that's all.
Oh.
So so this is actually these are some charts from actually like a very early version of what we've been working on, where this is looking at the data from inside and saying looking at memory, looking at uptime, looking at CPU time, and seeing how we can get some more information out of the system. And so then these are examples of actual charts where we saw some operational issues. And so this is pretty interesting. So the first one, you see a SAW pattern. And what that actually is a memory leak. And the reason why you see the SAW pattern is because, a great way to fix memory leaks is turning it off and on again, turns out. It works for a while. So this worked for a while, but ultimately, better not to have a memory leak. And so this is the kind of information that they allowed the user to go and figure out where the problem was and fix it. And the second one, that's actually you see, so these are invocation durations, and you see a nice little cluster of outliers. And so what happened there was an upstream service ended up being a garbage collection issue. And so figuring out that this upstream service was causing this strange spike in durations allowed, let the person go in and fix the garbage collection issue, and thus have a more, a beautiful chart is a predictable chart. So that's really what we're looking for.
So I just want to add a little bit more to the top.
Yeah.
That turning it on and off again, those were actually cold starts. So,
yeah.
This function was evoking several times per second, actually. And even with that, rate of execution, what was occurring was that the VM, because we can actually see the VM level and the container level that's operating underneath of Lambda, we can actually see get visibility into that, and we could see that those VMs and those containers were being recycled every 4 hours, no matter what. Well, not no matter what, almost no matter what.
Does that mean you want to talk about cold starts?
No,
Next slide.
Next one, real quick. But this would also reset, it turns out. If you run out of memory, then that's when you're going to have a retry, and it's going to restart that process. So what we ended up doing was bumping up our memory tier because we didn't want to experience retries, but we could have kept our memory tier lower, let that kind of hit the ceiling, and it would have restarted the process, and we would have had retries.
But now cold starts.
Cold starts, yeah. So that was actually a good segue, unintentionally. So what we did is we evaluated, several users and looked at the maximum invocation time for their containers and their VMs, and we could see that this generally stayed within the 4-hour window. It does seem to be actually trending up a little bit over time, but it's about the 4-hour window maximum that your VM and your container is going to live. There are some notable outliers here where Amazon was either having outages or doing maintenance. So they actually acknowledged August 12th on the left-hand side, and they said that there were increased errors and retries occurring, which I suspect was because users, well, first of all, they weren't reaping those VMs, right, which is the first problem. And then the second problem was that users were seeing more retries and more errors because their processes were living longer and they're running out of memory and they're running out of disk, and like those leaks, right, and those problems in their applications meant that when those VMs weren't being recycled, those retries were occurring. And then on the right-hand side, it actually happened again later, but then it was never acknowledged.
So the way we personally, so this is so how we do it. We in order to see inside the application, we get inside the application. That might, that's how we happen. So you import a library or you use a decorator, and it gets system information from the runtime, including timing information, stack trace reporting, logging, and events, and then that's inside, and then it also looks outside the application at the container and VM level.
Oh yeah, so it runs automatically. Yeah, so this is a little thing I put together called Lambda shell, and it's just a little shell. Actually, every time you evoke a command, it runs a Lambda and gets the standard output. And this is just a little tool that we put together because I use this to explore the Lambda, look at the environment, really understand what's happening behind the scenes.
It's also really fun.
Yeah, it's just a little fun thing, but it was actually, for us, it was really useful. There might be some use for users, like figuring out a way to turn this into a developer tool, but for us, it was a really great way of really understanding and getting inside that Lambda black box. Like, this is how we figured out things like, what's the VM separation, what's the container level separation, right? Using this tool and then like wrapping this tool and running it in concurrency at like 100,000 Lambdas, makes it really easy to figure out what's actually happening at scale. Is this me?
Yes.
Oh yeah. So so we can see that we use the containers, cold starts by the VM, the container, and the app process, right? We have an understanding on the it can be figured out, right? The life cycles of each of these, the tenancy of those VMs, that is like how many containers are being pigeonholed and running on each of those VMs, any external processes that you spawn, right? And we can like easily dig into the proc and the kernel and figure out really what's happening in the kernel, what's happening in proc, at least to the degree that we can as a non-root user. And we want to empower, right? And we want to, IO pipe, what we're doing is we're trying to extract actionable metrics from inside and outside the function. We look, again, inside the application, and we look out to the operating system, to the kernel, and the Lambda environment to figure out really what's happening for your app. We are looking at adding custom metrics and ingesting CloudTrail for context-aware intelligence about application state, security, etc. and we want to produce events. So when we see things occurring, when we see that those invocation times are creeping up, let's say that there's a problem and we see that one user's cold starts are increasing in that region, then we know that most or all users are going to have increased cold starts. So then we can maybe trigger Lambda functions for you so that will help you repair your infrastructure or maybe scale out some other parts of your infrastructure if there's some sort of impact that might cause for you. And then real-time metrics, real-time visibility, because we have an ingestion platform that is real-time. We pull in data, it's all event-driven, and we can deliver we will be able to deliver things within a second or two to our dashboard. We're almost there. We're actually technically there now. You just have to refresh it.
Anyway.
Yeah. Oh, did we fix that?
Yeah.
Oh, cool. Awesome. Okay. I don't do front end. So.
So we actually have I have a little demo that will involve me yelling at my computer. So hopefully this is enjoyable, and if you've zoned out, this will really kick you. So we're gonna try an Alexa skill, and so if you haven't gotten to see this, is pretty fun. There's Echo Sim is a browser-based simulator for the Echo. So if you wanted to play with Alexa skills and you don't have an Echo, well, no problem. You can use Echo Sim. It's really neat. So let's try something. Demo gods, hello. Thinking.
I'm not sure what you meant by that question.
Okay. That's why I made the invocation demo gods, because we know that the demo gods are very finicky. So, demo gods, hello.
I wasn't able to understand the question I heard.
All right. Well, luckily, we have a fallback. It's pretty fun. So you won't be able to see the audio. I do have a little video here running through the developer console. So here we have in the Amazon developer console, we have a skill. We can go in and look at it. I had already configured it. So we have the skill information. Of course, we have to ask the demo gods in order to run it. We saw how well that worked. And so you have your intents, and I have some sample intents, utterances. And so if we say hello, and so we ask the sample skill, makes a Lambda request, and we see that it'll say hello Serverlessconf, and so that's what Alexa should have said at you. But if we say something that doesn't make sense, like potato, we ask the Alexa, and we got one error, and then we want a different error, and this also says an error, and it's a very simple Alexa function, so you can look at the code, so and then this is looking at the data that came out of it. So we're logging into the dashboard, and this is in the beta, which you can join if you want. And so we can see there were some function invocations. So these are the batch average function execution length. And if we go and functions over time, and we look at the function page, so we can see that there were we had some invocations, and then we had a bunch, a couple errors. So when it tried and failed, and when it tried and then got there was actually a handler that throws an error. So, and then the error that it throws is snap. And so we can see some nice errors coming out of there.
Yeah, and then I think it's in staging or dev right now, but you can actually dive into the single invocations as well, and then look at the memory per invocation. Look really at the Lambda environment and understand what the operating system looked like at the time, and the system state looked like at the time that function aired. So you can understand if maybe there was some sort of systems error that may have been more than simply your code, right? Because these Lambdas, like the containers, live for more than the life cycle of a single execution, right? You can have what I call cross invocation errors.
Mm-hmm. Well, and also in Alexa, there was an interesting one I saw earlier today where I was able to see an error from an unrecognized. It actually hit the skill, but it threw an unrecognized handler error, and so that was pretty interesting. So you can discover new and interesting errors.
Yeah, Yeah, and the other thing is we're also looking at supporting other platforms. Right now, we only we're only building for Amazon right now because that's what's popular and used. What?
Oh no, it's okay. I was just stopping the video from going again.
Oh, sorry. Okay.
You're good. Keep going.
So we are looking at Azure and OpenWhisk and Google Cloud Functions and some of these other platforms. And we're getting there. We actually, just last night, I built, you can find it on my Twitter, I put together, a function on Azure that does web browsing inside of Slack, right, using Azure. And then we can do things like, build IO pipe wrappers for these other platforms.
Did you end up using Phantom, or did you do the ASCII rendering?
No, yeah, it's ASCII rendering using links. Yeah, it's like, yeah, it's pretty cool. Oh yeah, listen to me.
Yep.
So those getting help, right? You need to build and operate these applications, and sometimes you need help. So reach out. First of all, if you're using us, you can get on our Slack. We have a free beta you can register for. There's a link on the next slide. There's forums from Amazon, mostly Alexa stuff there actually for some reason. I guess Amazon pushes a lot of Alexa. There is a Gitter for the serverless framework. The serverless forum Slack is really cool. There's not a lot of developers in there, but I would like to see more people in there because that's a really cool Slack. Matt Weigel over in Seattle set that up, and there's a lot of really great developers in there. Really like a lot of cutting edge people. A lot of the tool builders are hanging out in those channels. So. Great.
Well, and then as promised, if you are interested in the beta, it's obligatory. We have to tell you about it. So so you can go there. And thanks so much. We're happy to, if we have some time for questions, we're happy to take them. Thanks.
Hello. Hi, I've got a quick one.
Wait, where are you?
Thanks for that.
Okay, great.
How much overhead does it add?
Yeah, so there's no overhead to the execution itself of the code, like as it's running. We do run a little bit of code before your function runs, and some code that runs after. At the beginning, it's like collecting like what time it is on the system, some basic things like some information out of proc, just reading a couple files. At the end of the execution, what we need to do is submit to our API. So that can take several milliseconds to make the REST call. But it's literally as quick as you can connect to our API, dump some data in it, and disconnect. We do that asynchronously, so we don't hang around waiting for it to ingest it into our platform. We just grab the data from your connection and then give you a 200 response and let you go on your way, and then we throw into things like Kinesis and let it run. Mm-hmm. Any other questions? Okay.
All right, thanks.
Thank you.
Thank you very much.